Hello again, Kevin Culp here from Supermicro. Today we're going to step into our sandbox and give you an understanding of how SEC's unified dashboard can support third-party compute. Before we jump into the SEC GUI, I thought it would be beneficial to take a look at redfish endpoints for a Dell and HPE use case. Today, SEC supports redfish version 1.8, which is exposed in Dell's iDRAC 9 and HPE's ILO 5 releases. Although redfish is exposed in these general implementations, both vendors still rely on cryptic IPMI command sets to lock customers into their proprietary management tools. SEC's open distributed architecture follows a standardized redfish framework, allowing SEC intelligent agents to parse redfish endpoint responses, harvesting the necessary metadata to be exposed within SEC's API front-end GUI. Before you jump into redfish queries, you should familiarize yourself with basic RESTful request methods such as post, get, put, delete, trace, connect, patch, and head. Other things that might be useful to your success would be a basic understanding of header fields, response, status codes, security access control methods, and security vulnerabilities. To understand the redfish standards, you might want to review the standards themselves by plugging in the following URL: https://redfish.dmtf.org/. Be mindful of the version level as well, which usually is referenced by the date of the release. Nifty tools like Postman, Swagger, and curl can be your friend when initiating such HTTP request. So how do I perform a redfish API call? So we're going to go ahead and log into the SEC kernel appliance, which you see here in my SSH session. We're going to initiate these curl commands, which really we're going to take a deeper look into the actual schema and see what kind of attributes or payload is in these actual redfish queries that we do. So before I start, I'm just going to go ahead and type in history, grep, and then curl, because I really don't want to do all the typing that exists for each one of these. So let's start with the Dell one first. The Dell particular machine is basically what we refer to as 172.24.199.7. We'll go and look at that server a little bit later in our GUI once we provide the lifecycle management within SEC. But let's take a deeper look at the actual redfish command. So it's this one here that I'm pointing to on my mouse, which is the 199. So in order to execute that, we can simply do a bang 1 and then 999 3 nines, and then issue the command, and presto, the command comes up and gets executed. So let's look a deeper look at the actual structure of this endpoint. So we see various different metadata that we can collect that our agent within SEC parses to get the valid information we're looking for to provide and expose those necessary information that's going to be rich for a architect to be able to look at. Things like the thermal of the fans themselves could be interesting. Whether there is a RAID controller inside this server itself. Maybe we want to take a look at processor and memory within this system, the type of PCIe devices that are inside here, and the power supplies, a CPU socket. So why don't we look at the CPU socket? So this is a 2-NUMA region type of server, 2-socket. So let's look at the actual endpoint to take a look at CPU socket. You'll notice here we're looking at basically chassis. So to actually look at the socket, we need to also look at the endpoint, which is basically system. So let's go ahead and change, instead of looking at chassis, let's walk the endpoint here. We're going to type in systems, and at that point it's going to show information about the server itself. Now it's possible here I might have done a typo here because it's not coming back with the appropriate information I'm looking for. It's basically hanging. So let's go ahead and come back to the chassis again and see what typo we did. So the clue was it was sort of hanging there and not being able to respond. So let's go ahead and see why it was hanging. So let's look at system related information. So we'll scroll up here and get a clue of the endpoint that we want to parse itself. So let's use the systems attribute here. So we're going to change this to capital S, systems, and I think at this point we want to make sure, let's go and just look at systems itself. And there we go, it responded. So I had a typo in the previous one. And let's look at systems so we see the type of processor that's inside this Dell box. It's an Intel Xeon Platinum 8176 at 2.10 gigahertz. And then we can also look at support for storage and simple storage. So let's scroll up here and see if we see, we see all kinds of other metadata here that's of interest potentially to us. And then if you look, you can also look at basically memory itself too and PCI devices, PCIe functions. So basically parsing each one of these, we actually can see the appropriate information. So let's look at processors now. And so now we want to put at the end of this the word processors. Instead of me typing it, let's just cut and paste it because I'm lazy, and click on the return key, and we'll see what we could see both socket 1 and socket 2. It's a socket 2-socket server. So let's go and plug in socket number 1 and cut and paste that in and hit our return key. And we see information about socket 1. We see the CPU family here. We also see this is definitely CPU 1 and socket 1. It shows you the number of cores, which are 28, the threads, which are 56. So some very useful information that you can look at and expose within your lifecycle management itself. So we parse this data through our intelligent agents within SCC, and we basically go through the hierarchy and pick out information that we feel is going to be useful for the administrator. So that's the Dell box. So let's look at now the HP box that we support. So let's hit the history command again and grep it to curl, and let's look at the HP box. So the HP box is this one here that we're going to look at. And then we're going to execute that command by hitting a #2005, and at that point it'll respond and give us the metadata we're looking for. So in this case, or this use case for HP, maybe we want to take a look at the manufacturer itself right here, and then maybe the type of model for the HP server, which is a ProLiant DL30 Gen 10. and let's see what kind of processor is in this particular chassis. So we can simply hit the arrow key and type the word systems here, capital S for systems, and we see systems here. And let's look at the type of processor. So we know the type of model. CPU is in here. It's a Bronze 3104 CPU, slightly a lower gigahertz rating, which is a 1.70 than we saw on our Dell box here. And let's plug in the processor here to get that metadata. And so we're going to cut and paste it and hit the no colon on the end. We see processors, again, a 2-socket type of server. And let's look at processor number 1. Let's look at how many cores it has and threads. So here it's showing CPU 1. And we're showing 6 total cores and 6 threads. Some other useful information here is the again, the type of model it is. Let's look at the second CPU in here. So we just change it to 2 here, and we can see the data for of total cores is 6 and total threads as 6. So that's how you actually walk the hierarchy of the schema. So we showed you both the Dell use case and HPE use case. As I mentioned, we have intelligent agents that go out and parse this data. Both the iDRAC 9 is the source of truth and the ILO 5 is the source of truth. We get that data from those endpoints and then organize it into a unified dashboard, which is useful for the system administrator to be able to perform the necessary system lifecycle management. Now that we've had our basic understanding of walking the redfish schema, let's dive into the SCC GUI and explore system lifecycle management next. See you next time. Thanks for joining.